Welcome to the Spring Security video course. This course is going to show how to use in practice the powerful Spring Security framework using pragmatic examples relevant for actual development. Throughout the course, we're going to be working with a web application, and this will be unsecured at first, but as we complete each section, it will become more and more secure and production ready. Let's start by looking at where the code for the course is hosted. As you can see, the code is hosted in a Git repository living on GitHub. This is a public repository with no access restriction. The codebase is organized and broken down by section. And each section, if we go into it, is further broken down by video. Each video represents a project, and this can be imported and worked on independently of any other project in the course. So let's look at what these 7 sections will actually discuss. In the first section, we will set up Spring Security for the project. In the second section, we will deal with registration. We will then move to the Remember Me authentication mechanism. Next, we will integrate LDAP with Spring Security. We will then discuss Spring Security expressions, and we will look at the various types of authorization that are available to us. In the 6th section, we will implement authentication and authorization for a RESTful service, and we will finish the course by looking at some advanced functionality, access control lists. Now let's quickly talk about resources and references. Each section has a list of recommended resources that can be further explored to better understand the subject. For example, if you go into a section, we will find section references. These will mainly be links to the Spring Security official reference, but we will also find, for example, for the registration section, we will find links to the JPA official documentation, to the Hibernate documentation, and a link to the SQL scripts used to generate the table structure. So let's now clone this repository. We're going to copy the clone URL from here, and we're going to clone it. And we are done. Let's now fire off Eclipse and let's import the project. Okay, so we are in Eclipse. We're going to import the project by simply going to Import Existing Project into Workspace. And so let's import the first project in the first section. Of course, other IDEs such as IDEA IntelliJ are perfectly fine to use, as all these projects are Maven projects, which work with pretty much all major IDEs. Let's also quickly define a web server in Eclipse. We're going to be defining a Tomcat 7 server. Let's add the application to the server, and let's start it up. Now, of course, the web application is a standard WAR file, so it can run in any standalone server as well. We're only using the Eclipse managed Tomcat server for convenience. Okay, now let's look at the application itself. This is a simple and relatively standard user manager. It is able to show users, and for now, nothing more. And of course, at this point, as we mentioned before, it is completely unsecured. We are going to enable and set up Spring Security to secure this application in the first section of the course. Before going forward to the first section, let's quickly discuss a core feature of Spring Security 3, one that we're going to be consistently using across the entire course, and that is the XML configuration. There are 2 ways to write the Spring Security XML configuration. The first is defining the raw beans that are going to make up the Spring Security infrastructure, and the second is to use the namespace support. The namespace support in Spring Security is effectively a shortcut. It is a convenient way to set up the configuration without having to write raw beans manually. All the functionality that is achieved by the namespace support can just as well be configured without it. Only, of course, defining all the raw beans that are going to make up the security configuration will be a lot more verbose. The overall approach of this course is very practical. We're going to be learning how to solve the common security problems in a web application. Sometimes, however, a more in-depth discussion may be necessary. either on core Spring, and on this the Spring reference is a very good place to go in depth on the framework itself, or of course on Spring Security, where the reference is also the best resource to get into that kind of detail. And the Java docs are of course a good place to look at the low-level details of the API. This is the first section in the Spring Security course. In this section we will secure the Java web application shown earlier, and we will cover some of the most common use cases in Spring Security. The section consists of 5 parts. We will start by securing the user management web application with the most common authentication mechanism, form-based authentication. Next, we'll set up login and logout, and we'll set up our users and some authorities. We will then do some simple role-based authorization on full URLs. Next, we'll take a look at Spring Security expressions, and we will cover some practical use cases with the most common built-in expressions that the framework actually provides. We will end the section by doing our first real customization. We will have the landing page after login show us different links based on what the user is able to do in the system. This is useful for a scenario where an admin user would see a different set of links than a standard user would. In this first video, we will implement a basic form-based authentication mechanism with Spring Security. We'll start by setting up our Maven dependencies. We will then configure Spring Security in our web XML. And finally, we'll define our security XML configuration. So, first thing we need to do is to set up Spring Security as a Maven dependency. Let's take a look at our POM and at our existing dependencies. As we can see, Spring itself has already been defined as a dependency for our project. So the next step is to add the Spring Security specific dependencies to our POM. We're going to add Spring Security Web and Spring Security Config. So let's uncomment these. And let's take a look at what Maven will actually resolve at runtime. Right off the bat, we can see that something's not right. We have all of these 307 dependencies alongside our correct 321, when we should only really have 32 dependencies. What we need to keep in mind here is the way Maven resolves conflicts. It will choose based on a shortest path mechanism, which means that we have a shorter path for all of these 307 dependencies than we have for our 321s. The way to solve this is to override all of these dependencies in our own POM. So we'll need to uncomment all of these, and this way we can make sure that the shorter path is our own path, so the 3-2 dependencies have priority. Now let's check how this looks at runtime. And everything looks good. Now we only have 3.2 dependencies for all our Spring core libraries. Alright, now let's enable Spring Security in our web XML. Internally, Spring Security is using a servlet filter in order to enable its security features. So we only need to add this delegating filter proxy, which is a Spring Security filter, and map all requests to go through this filter. Okay, let's uncomment this and we should be done. We can now finally move to the last piece of the puzzle, which is the configuration. So for the configuration, we are using the rich namespace support that Spring Security puts at our disposal instead of defining individual beans for each and every configuration element. This is very useful even for the more advanced and custom scenarios, but especially when starting out with Spring Security. You can see here that the configuration at this point is very simple. We are defining an authentication provider which has users defined in clear text. Of course, this is only for demo purposes, and we will move to something more secure later on in this section. Also, take a look at the HTTP configuration. We are securing /admin with is authenticated fully. This will require that the principal is fully authenticated before being able to access any /admin prefixed page. This is especially important because this is the main URL of the web application, so basically that is what we want to secure. And finally, let's activate the XML configuration. We're going to use this simple config class This is marked with add configuration, and it is importing the resource from the class path. Also notice that this entire package is automatically scanned for any configuration classes, so these will be automatically picked up by Spring. And now let's restart the server and let's see this in action. At this point, a login form should appear when trying to access this admin users page, which is secure. And indeed it does. This is an auto-generated login form located at Spring Security Login, and this is the default login URL in Spring Security. So let's log in. We will go and pick up the username and the password, and we have logged in. It is that simple. Now, of course, with Spring Security enabled, we can no longer load up the users. And this is something that we will work on in the next video of this section. So, at the end of this video, we have used Spring Security to secure our first web application. In this second video, we will focus on authentication. We will start by adding login support in the XML configuration of our Spring Security application. We will then configure a landing page for the user to be directed to after login, and a page for unsuccessful authentication. We will then define a custom login form, and we will end this video by configuring logout functionality. Let's start by adding a login form. We will add the form login element to our Spring Security XML configuration, and if we don't specify anything else to the form login element, Spring Security will auto-generate a very basic login form at /Spring Security Login. So let's take a look at that. This is a simple login form that Spring Security has auto-generated for us. It has a username, a password, and a login button. And as we said, the URL is Spring Security Login, which is something that we will want to change later on. So at this point, we should be able to log in with user 1. And we are logged in. But notice that the login process has not taken us to any new page. We are still on the home page. So there is no visual way to tell that the login process was successful. And this is what we will change next. So the next step that we will want to implement is to change where the login process takes us. We can do that via the default target URL, and we can set the authenticated HTML page as our target after login. Let's restart the server and let's log in again to see this change in action. So we're going to log in with user 1, and indeed this time we are redirected to the authenticated HTML page instead of the home page. So now let's move off of the auto-generated login form and create a custom login form. This is a very simple login form, and the elements that are worth noting here are the two inputs and the action of the form. Now we need to get this exactly right. JUsername, JPassword, and JSpring Security Check are the defaults in Spring Security, so if these are not correct, then posting the form will not have the intended effect and login will not be performed. Let's now define this custom login page in our security configuration. So we're going to point to the login HTML, which should override the older Spring Security login page. So let's restart the server and let's see this in action. First, let's verify that the default Spring Security login page has indeed been overridden and is no longer available. And indeed it's not. We are getting a 404 for it. Now let's go to the new login page, which is present at /login as configured. And now let's log in. Okay, and everything works as expected with a new and custom login page. Okay, now let's take a look at how an invalid authentication process looks like. We're going to try to log in with an invalid user. So now the authentication process has failed, but the problem here is that we are not able to visually tell that it has failed. There is nothing changing in the URL and there is nothing on the page either. So we will need to instruct Spring Security to redirect to another page when the authentication process is failing. We can do that via the authentication failure URL on the same form login element. And here we can actually reuse the same login HTML page and just customize that with an error equals true parameter. And then the page can read this parameter and display an error. So let's restart the server and let's make sure that this URL actually changes when the login is not successful. So let's log in again with an invalid user. And now we are actually getting the error equal true in the URL, so we are able to tell that the authentication process was not successful. Overriding these defaults is clearly going to be required for any non-trivial application out there, but there is another reason why we don't want these defaults in our web application. And that reason is that we don't want a potential attacker to be able to determine that we are actually using Spring Security to secure our system. An attacker that is aware of that information would be able to orchestrate much more sophisticated attacks and would be able to exploit the known issues of the framework. And finally, let's implement the last piece of the authentication process, which is logout. Spring Security comes with its own logout URL, but this is not yet configured in our security configuration. So if we log in with user 1 and then try to log out, we are getting a 404 for the J Spring Security logout URL because logout is not yet set up in our project. So let's enable logout. This is simply done by defining the logout element in our HTTP main element. Let's restart the server, and at this point we should be able to log in and log out just fine. So we're going to log in with user 1, and now we should be able to successfully log out. And we are. However, notice that the logout process does not take us back to the login page, it takes us to the home page. So this is the next thing that we would want to change. We want the logout process to take us back to the login page. The way to do that is to configure a logout success URL. This is going to be the URL where, if successful, the logout process will take the user to. So we can set that to login HTML, and so now the logout process will direct the user to login HTML. Let's restart the server and let's see this in action. So we're going to log in with user 1, and now when we log out, we should be redirected to the login form. And here we are back on the login form. The working logout concludes this video and leaves us with a well-crafted authentication for our web application. Login and logout processes are taking the user to the right pages and can form the basis of a production-ready Spring Security environment. In the previous videos we have discussed authentication, and in this video we will be looking at what Spring Security provides in terms of authorization. One of the most common requirements of a web application is to be able to secure certain URLs and to only make these accessible to certain users. We'll start by defining our first authority in the Spring Security XML configuration, and then we will secure our first page by its URL. So let's analyze our current URL structure. As we can see, we are requiring full authentication for all the URLs under /admin as well as for our authenticated HTML page. Also notice that we have defined two users, but these users do not yet define any authorities. So let's now change the access to /admin pages to require a specific authority. Let's say that this requires role admin. Notice that this is not an authority that any of our two users has at this point. Okay, let's try this out. We are logging in with user 1, which does not have the newly required authority of role admin, and then we are navigating to the user's admin page, which we should not be able to access. And indeed we are getting the expected 403 access is denied when trying to access the admin users page. Let's now solve this problem by adding the newly defined role admin authority to the authorities of the admin user. Let's restart the server and let's try to log in with the admin user. Okay, so now we are logging in with admin 1, and since this user is actually defined as containing the role admin authority, we should be able to go and access the user's admin page. And indeed we are. we are fully able to access the user's admin page. Let's try the same thing with user 1, which is still not defining the required authority, and we are still getting the 403 access is denied. Now let's secure our main authenticated HTML page with a new role. We're going to define role user, and we are going to set role user on both the admin1 and the user 1 users. Let's restart the server and let's see that we are able to still access the authenticated HTML page as user 1 and admin 1, but not as an anonymous user. So we are logging in with user 1, and as expected we are able to see the authenticated HTML page, same with admin 1, but now we are logging out, and then we are trying to access the authenticated HTML page again. And of course we are not able to. We are redirected back to the login page by Spring Security, which prompts us to authenticate. At the end of this video, we have secured our first URL with a custom defined authority specific to our application. This mechanism is still relatively coarse, so in the next video we will start to look at a mechanism that gives us more fine-grained control. So in this fourth video, we are going to look at authorization expressions. We are going to start by enabling Spring Security expressions for our application. And then we're going to discuss potential problems after expressions are enabled in the Security XML. We're then going to use simple expressions to secure the URL of a page. We're going to use the hasRole expression. Next, we'll learn how to use deny all and permit all, and we'll discuss why the order of the URL element definitions is important. We'll look at a practical example of using isAnonymous, and we will finish by concatenating two Spring expressions to form a more complex expression. So let's begin this video by looking at some practical examples of expressions that Spring Security provides. First, in order to use expressions, we will need to enable them. Without this step, using an expression will result in an exception at startup. Notice here that we have used our first expression. So let's start up the server and let's see this error occur. Spring Security is signaling the usage of an unsupported configuration attribute, and this is actually our expression. So in order to use this kind of expression, let's first enable expressions globally. We do this by the useExpressionTrue attribute on the main HTTP element. So let's restart the server and let's make sure we have no more exceptions. Okay, so everything looks good, the server is starting up correctly, but there is one additional detail that we will need to consider. Once expressions are enabled globally for the entire HTTP element, all the access attributes need to have valid expressions, and role user is not a valid expression. This will mean that when Spring Security hits this authenticated HTML URL, it will fail with a runtime exception. So let's see that happening. We're going to log in with user 1, and indeed we get a runtime exception, fail to evaluate expression role user, since we have mentioned this was not a valid expression. So let's go back and change that to a valid expression. And let's restart the server. At this point, we should be able to log in successfully both with admin1 and user 1. So we're going to log in with user 1, and everything looks good. And now with admin1, and we are logged in correctly. Okay, so we had a look at hasRole, now let's take a look at hasAnyRole. So for this expression, it will be enough that the authenticated principal contains any of the authorities provided as arguments. So we will define a new authority, role new, and notice that role new is not configured for either admin1 or user 1, but both of them do contain the role user, so both of them should still be able to fully access the authenticated HTML page. So let's try that out. We're going to restart the server, and we are going to log in first with user 1, and we are fully able to see the authenticated HTML page, and then with admin 1 with the same result. Next, let's quickly look over the permit all expression. So let's say that we want to permit access to the user's admin page for all users while still keeping all other admin pages fully secured. So we will need to define another intercept URL specifically for the user's admin page, and we will need to secure that with permit all. And we should be done. Let's restart the server and let's see this in action. So we are going to log in with user 1, and we want to make sure that user 1 is now able to access the user's admin page since it wasn't able to before. And it is. User 1 is fully able to access /admin/users. Now let's make sure that user 1 is not able to access some other admin page. So we are going to go to some other page, let's say users 2, and we are getting the 403 access is denied, as we should be, because only the /admin/users HTML page was configured with permit all. Now keep in mind that the order in which these two intercept URLs are defined is relevant. The more specific one needs to come first, and the more general one, securing all /admin pages, needs to come second so that the first one will get applied. Finally, we will end this video by looking at how two or more Spring expressions can be concatenated with logical operators to form even more powerful expressions. For this, we will add another user, admin2, and we will secure the admin users page to only be accessible to this new user. So we're going to secure it with has role, and we are going to secure it with an additional expression that works directly with the principal. So for the admin users page, only admin2 should be able to access it. So let's restart the server and let's make sure this is indeed the case. We're going to log in with admin1, and we should not be able to access the admin users page, and indeed we're not, we're getting the 403 access is denied. But now logging in with admin2, we should be able to access the page. And indeed we are. At the end of this video, we have used in practice the most important Spring expressions to secure full URLs. In this video, we will focus on in-page authorization. We'll start by adding the required Maven dependencies to enable this mechanism. We will then show how to enable taglib support in the JSP page. And finally, we will show or hide an in-page element based on security concerns. Let's start with the problem. If we take a look at how the authenticated HTML page looks for user 1, we can see that we have a link to the user's admin page, even though user 1 is not able to access that page. So the next step we'll want to do is to conditionally show that link based on whether the user is able to access it or not. So the first thing we'll need to do is to enable the Spring Security Taglib's Maven dependency in order to be able to use the taglib support. Next, we will need to enable the taglib support in the JSP page. We will do this by defining this new taglib here, pointing to security tags. So we have uncommented this, and now we can move to actually showing or hiding that link. And finally, we can actually use the taglib support to show the link on the page. This uses the sec authorize tag and the exact same expression that we previously used to secure a full URL. So let's restart the server and let's see how this behaves for user 1. Logging in with user 1 should not display the link on the page. And indeed, the link is gone. Now logging in with admin1, we should still be able to see the link because admin1 actually has role admin as an authority. And here we go, the user's admin link is still present on the page as it should be. And this concludes section 1, basic authentication and authorization. At this point, we have implemented both authentication and authorization for a simple web application. The user is able to log in, log out, only access the URLs that he is allowed to access, and only see the in-page elements that he should be allowed to see. The only part of the configuration that is not yet production ready is the authentication manager, which is still an in-memory implementation, so this will be the focus of the next section. In this second section, we will focus on the registration process. First, we will implement registration against the in-memory authentication provider from the previous section. Then, we will implement registration against a JDBC authentication provider. And finally, we will configure JPA with Hibernate, and we will implement the registration process using a custom JPA-based service layer. For the time being, we are still working against an in-memory authentication provider. The authentication manager element will create an in-memory user details manager. This is a non-persistent implementation of the user details manager interface, which is backed by a map. So let's start by looking at the registration page. Since we're going for a production-ready implementation, the registration page is going to use Ajax to submit the request, as that gives us much more flexibility in terms of interacting with the registration API on the back end. As you can see, the UI is very simple. We have the username and the password input fields, and the third input field is just the password repeated for security purposes. Next, we have the Ajax registration. The doRegistration method is invoked when the form is submitted. Next, we have the form submission. Notice that the form itself has no action. That is because the registration request is going to be sent via Ajax. So let's look at that. When the form is submitted, the doRegistration request will be sent to the server. This is defined in the registration JavaScript. So this is a simple method that just extracts the username and the password from the UI, creates a simple registration DTO, and sends that to the server in a post request. Now let's look at the backend. This is the registration controller and the registration DTO. The registration DTO is a straightforward object which simply maps to the JSON that we just defined on the front end. It only contains the username and the password. The registration controller still interacts with the user details manager. This is the in-memory user details manager that we have mentioned at the beginning of this section. Also notice that we are currently only registering a user. This is because we have hard-coded the role user in this controller. We could of course provide a register admin method, which would pretty much look the same as this one. Okay, now let's see everything working together. So let's register. I'm going to register user2. And now let's make sure we can actually log in with this newly registered user. And we can. We are logged in. And finally, the registered user should not survive a server restart. So we have just restarted the server. And we are now logging in with user2 again. And we are getting error true, which meant that we could no longer authenticate with user2 as expected. So the user did not survive the server restart. At the end of this video, we have implemented a simple registration mechanism both on the front end and on the back end. In this video, we will finally implement a persistent authentication provider. We will start by adding JDBC support in our project. We will then create a database schema and a table structure that is going to be required by Spring Security. And finally, we will make use of the out-of-the-box JDBC support in Spring to persist newly registered users. We're going to need a few additional dependencies, so we're going to open up the POM. And we are going to enable the MySQL connector. We already have Spring JDBC defined in our POM. The next step is to create the schema and the tables that Spring Security is going to be using. For this, we have a couple of options. We can either leverage the support Spring Security itself has. The reference contains the SQL scripts for creation of this schema, or we can create our own table structure. If we do create a custom table structure, we will then need to override the default queries that are used by the JDBC support in Spring Security. We could do that via the namespace, but since this is a greenfield project, there is no need for a predefined custom table structure, so the default ones will suit us just fine. Alright, so let's go ahead and create the default table structure. Let's refresh, and we can see the new tables being created. Let's also add a few predefined users and roles. And that's it. Okay, so let's check out the table schema that we just created. As you can see from this diagram, the schema is very simple. It only has the two tables and the relation between them. And remember that the scripts used to generate these tables and the data are in a setup SQL file in the project, and as I mentioned before, they're in the Spring Security reference as well. Now that the correct table structure has been created, let's go ahead and swap this in-memory user service for a JDBC back. So we're going to use the JDBC user service element, and we're going to simply define a data source, and Spring Security will take care of everything else. Let's restart the server, and let's make sure we can still log in with our previously defined users. And we can. We are logged in with admin1, and this is able to access users admin, but not the super secure dev only page. Admin2, however, is logged in, able to access users admin, as well as the super secure dev only page. And user1 is logged in, but not seeing anything else. So we were able to log in with all our previously defined users, and their authorizations were correct as well. Let's now register a user. Let's restart the server. And let's make sure we can still log in with this newly registered user, which was the entire point in using a JDBC backed authentication provider instead of the in-memory one. And we are able to log in after the server restart. That means that user 4 has indeed survived the server restart. Let's also query the database and see that user 4 does indeed exist along with all our old setup users. So we can see admin1, admin2 and user 1. These were users that were created in setup, and now we have user 4 as well. At the end of this video, we have implemented our first persistent authentication provider backed by JDBC. In the next video, we will move off JDBC and to a more mature and high-level JPA-based solution with Hibernate. Having now implemented the JDBC-based authentication, we saw that we needed to work with raw SQL and with database-specific syntax, in our case MySQL. In this video, we are going to switch to a more common and high-level stack, JPA and a JPA provider such as Hibernate for the persistence layer of the application. Note that the authentication mechanism is flexible enough to support many other types of providers, for example, providers backed by NoSQL storage such as MongoDB. We have already seen an in-memory provider as well as a JDBC-backed provider, and we will have a look at a more advanced LDAP authentication provider later on in the course. We are going to set up JPA, Hibernate and Spring Data in the project. Then we are going to implement a custom user service for authentication. And finally, we will make the registration backend interact with JPA and our custom service layer. With that in mind, let's add JPA and Hibernate into our Maven POM. We're going to add Hibernate Entity Manager, which has Hibernate Core as a dependency, and we're going to be adding Spring ORM for the basic ORM support that Spring has. We're also going to pull in Spring Data JPA to simplify the persistent layer. So let's uncomment these and we're done. Now we are going to briefly look at the persistence configuration, but since persistence is not the main focus of this course, we will not go into too much detail on this. So the backend persistence config is defining a data source, a transactional manager, the entity manager factory bean for Hibernate, and it is also enabling transactional management support for our application. Now that we have moved to a custom implementation both for the authorities and the users, we will need to work with custom entities for each one. We will also need to work with a custom service layer. So let's take a look at the authority entity. This is a very straightforward entity, it just contains an ID and a name. Now the user entity is a bit more complex. It contains the ID, the name, the password, and of course a set of authorities. And now let's take a look at the services. So the user service is a very straightforward implementation. It is marked as transactional and is just delegating all of its operations to the DAO layer. The DAO layer is using Spring Data and is only defined by this interface with absolutely no implementation. That is the power of Spring Data. All of the queries are inferred from the fact that we are extending the JPA repository and the JPA specification executor, and from the names of the custom methods. Alright, so now that we have a good understanding of how our persistent layer, which is backed by Hibernate, works, we will need to switch off of this JDBC user service and we will use the user service ref to define a custom user service. So let's now create this custom user service. We are going to annotate this with service so that it is automatically picked up by Spring, and this will implement the user detail service interface from Spring. Now we are going to inject our own user service, and we are going to use that to retrieve the user by its username. Now notice that the return type of this method is user details, which is a specific kind of Spring Security user. So we will need to return from this method a new user from Spring Security. So we already have the username. We can retrieve the password, and now for the authorities, we are going to convert the authorities from the user to Spring granted authorities. And we are done. We now have a custom user service correctly implementing user detail service and retrieving the user by its username. So let's now start up the server in debug mode. Let's add a breakpoint here in load user by username, and let's study the authentication process in detail. So we're going to log in with admin1. And as you can see, the authentication process is providing us with the username. We are now retrieving our own user by this username, and we now have our own entity and our own authorities. These authorities will be converted, as discussed before, into granted authorities, because this is what the constructor of the Spring user is expecting. So we now have converted these authorities into simple granted authority objects, and we are now returning the Spring user back into the authentication process. And we are logged in. Now that we understand the authentication process, we can finally take a look at registration. The registration controller is working with the user and the authority services to implement this simple registration logic. Notice that we are only registering a user and not an admin, as we have hard-coded the user authority here, and the registration process is simply retrieving the authorities of the user and creating a new user based on the registration DTO. And finally, let's finish out this section by registering a new user. We are going to register user 2, and we are now going to restart the server and make sure that we can still log in with user 2 after the server restart. And we are logged in. This means that user 2 has indeed been able to survive the server restart. This section ends with a significant milestone. We have implemented a full, persistent, and production-ready registration process. We have also configured our authentication process to use the mature JPA-based persistence instead of the low-level JDBC solution from before. In this section, we will implement Remember Me functionality for our web application. But first, let's take a look at the problem. Each time a user tries to visit our system, they will have to log in, which is not ideal. Remember Me solves that problem. In simple terms, it is a convenient mechanism that remembers the authentication of the user next time they visit our application, so that they don't have to log in again. More technically, the authenticated principal is remembered across sessions. Spring Security has two implementations of Remember Me. The more common one is storing the Remember Me token in a cookie, and this is what we will be implementing in the first video. In the latter part of the chapter, we will implement the alternative Remember Me mechanism, which uses persistence to store these tokens. And finally, we will understand the details of both of these Remember Me mechanisms in Spring, and we will discuss the pros and cons of each one. In order to use the Remember Me functionality from Spring Security, we will not need to pull in any new Maven dependencies. Spring Security Web is all that we need, and this has already been defined. So now we'll need to see how the application behaves when the session times out and the user will have to log in again. So we'll go to our web XML and we will define the session timeout, and we do this by defining the session config element, and we are setting the session timeout to 1 minute. So let's enable this, and let's move forward to the web security configuration. So in here, all that we need to do is use the rich namespace support, add the Remember Me element to activate Remember Me functionality, and provide a unique key for the application. This can be anything, and we're using here a simple my app key string. We will finish up by adding Remember Me to the login form. So all we need to do is add this new input of type checkbox mapping to Spring Security Remember Me with value true. So let's uncomment this and restart the server. And now we should be able to see the Remember Me checkbox on the login form. Okay, let's log in with admin1 without checking Remember Me, and let's see how the session expiration behaves. So we'll have to wait for a full minute, and now that a minute has passed and the session has actually expired, we should be redirected to login when we refresh the page. And we are! The session expiration meant that we were redirected to login because the Remember Me was not checked. So let's log in with admin, but this time check Remember Me. Another minute has passed, so the session has expired again, but this time when we refresh the page, the Remember Me functionality should keep us logged in. And it does. Refreshing the page keeps the user logged into the application. At this point, we are able to set up a basic but working version of the Remember Me functionality for a standard Spring Security web application. In this video, we will dive into the details of the cookie-based Remember Me mechanism. We will start by analyzing the cookies when Remember Me is active. We will then discuss the Remember Me algorithm. And finally, we will change the Remember Me expiration time from the default of 2 weeks to 1 week. First, let's take a look at the cookie that exists in the browser after we log in with admin1 but without activating the Remember Me functionality. This is the standard JSessionID cookie identifying the current session, and this will be expired at the end of this session. Now let's log in with Remember Me activated, and let's see how this affects the existing cookies. So as we can see, we still have the standard JSessionID cookie, and this is still expiring at the end of this session. However, we can now see that a new cookie has appeared. This is the Remember Me cookie, and the main difference between the JSessionID cookie and the Remember Me cookie is the way these are expired. The JSessionID cookie was expired at the end of this session, and since the current session is now only 1 minute long, the JSessionID cookie will be expired after 1 minute as well. The Spring Security Remember Me cookie, however, will no longer be tied to the expiration of a single session. This is now expiring after 2 weeks, regardless of the current session. Let's now take a look at the details of the cookie value itself. This is a base64 encoded value composed out of a few artifacts: the username and the password, the expiration time. This is the time for which the Remember Me cookie will be valid, and by default this is going to be 2 weeks. And then an MD5 hash value of the username, expiration date, password, and private key. This is the private key that we specified in our web security configuration. So by looking at the type of information that is stored within the Remember Me cookie, we can infer the following. First, if the password is changed, then this Remember Me cookie becomes immediately invalid. But more importantly, if the cookie itself is captured, then the attacker can still use it until the time this expires. One final customization that we will do at the end of this video is changing the time for which the Remember Me cookie will be considered valid. We will need to do this in our security XML configuration. So we will need to set this token validity attribute on our Remember Me element and restart the server. Now, logging in with Remember Me activated should expire the cookie after 1 week instead of 2 weeks. And it does. One thing we'll need to keep in mind is that Remember Me is a convenience for the user, and as such it doesn't come without risk. The main risk is that the Remember Me cookie will be intercepted by a malicious user, thus compromising the user's session. While this risk can be minimized by using SSL and other techniques, it is still a real threat. At this point, we have implemented a simple Remember Me authentication mechanism with Spring Security. In this video, we will discuss the second Remember Me mechanism that Spring Security puts at our disposal. This is a more secure Remember Me mechanism, one that no longer relies on both the username and the password. In this implementation, only the username will be sent to the client, while the password itself is never part of the cookie. We will start the video by implementing the simple persistent Remember Me mechanism. We will generate the necessary table structure in MySQL, and we will discuss the details of the persistent Remember Me algorithm. Let's start by creating the database structure necessary for the persistent Remember Me. Let's open up MySQL Workbench and run the script. The script itself is taken from the Spring Security reference and is readily available. So let's run the script and refresh, and we see our new table, which is called persistent logins. Next, let's open up the Spring Security XML configuration, and let's switch the old mechanism, which was cookie based. Let's switch that to the new mechanism, which will be persistent based. So we can do that by adding the data source ref attribute to our Remember Me element, and Spring Security will take care of the rest. So now that the Remember Me mechanism no longer validates the signature being present in the cookie, but the fact that the token is present in the database, each time the user will be authenticated via Remember Me, a new token will be generated and persisted to the database, while the old token will be removed. An additional field, the series identifier, is also persisted to add an extra layer of security for attacks that compromise the cookie. Let's go through the high-level sequence of the authentication mechanism with Remember Me. First, a request comes into the server and the Spring Security filter chain starts executing. From the chain, we care about a specific filter, the Remember Me authentication filter. The first step checks if the Remember Me cookie exists in the request in the first place. If it doesn't, then the filter doesn't do anything else and the execution moves to the next filter in the chain. If, however, the cookie does exist, and this is indeed a remember me request, the next step is to try to decode the cookie. If this fails, an exception is thrown. If, however, it succeeds, the next step is to validate the cookie by checking its MD5 signature. And again, if this fails, an exception is thrown, and if it succeeds and the cookie is considered valid, the mechanism will check the user account and will try to perform the authentication process. And finally, if this last step succeeds, an authentication token will be created and the execution will move to the next filter in the chain. Now let's log in and see our cookies. We're going to log in with admin1 with Remember Me activated. The standard JSessionID cookie is still there as expected, and so is the Remember Me cookie, but now it's storing different information, the token and the series identifier. Also, now we should be able to see the corresponding token in the database. In MySQL Workbench, let's take a quick look, and here's our token for admin1, the series and the token itself, and the last use date, which was just now. Now that we have seen how Spring Security uses persistence to store these tokens, we need to mention one of the small downsides that the persistent-based Remember Me mechanism has, and that is that there is no default mechanism to clean up expired sessions. This is, however, very easy to build by hand. At the end of this video, we have implemented a more secure, persistent Remember Me mechanism for our web application. In the previous videos, we implemented two mechanisms for the Remember Me functionality. In this final video of the section, we will take a look at some of the more advanced functionality of Remember Me. We will secure a page with the isFullyAuthenticated expression, and we will understand how this expression grants extra security to the Remember Me mechanism, protecting against scenarios where the Remember Me cookie might be compromised. To minimize the potential for damage of such an event, Spring Security provides the fully authenticated expression to be used for the more sensitive parts of the application. When an URL is secured with fully authenticated, the Remember Me authentication will no longer be enough and the framework will prompt the user for his full credentials. For example, changing the password of an account, payment, or any other kind of sensitive operation can benefit from this kind of extra security. So let's take a look at how that works. First, we'll secure a URL to only be accessible for fully authenticated users. A user authenticated only with Remember Me is not considered fully authenticated. So we are now securing this new page, this full auth only HTML page, and we are using the isFullyAuthenticated expression. Let's restart the server, log in with Remember Me active, and wait for 1 full minute for the current session to expire. Now that 1 minute has passed, the current session should be expired. When we refresh the page, Remember Me should kick in and keep us logged in, but at this point we are no longer fully authenticated. So now, when we request the new URL, Spring Security should not allow the user to access it. And indeed we are getting the 403 as expected. This way, the more secured portions of the application are still protected without having to give up the convenience of the Remember Me mechanism. And this concludes the current section. At the end of this section, we should be able to set up the cookie-based Remember Me functionality in Spring Security. We should be also able to configure the more advanced scenarios of Remember Me with cookie. Next, we learned how to set up Remember Me backed by a persistent token. And finally, we used in practice the more advanced functionality of Remember Me, learning how to secure a page to require full authentication. In this section, we will set up our Spring Security authentication and authorization to interact with LDAP. LDAP is a very mature application layer protocol with wide industry support. The main benefit of using LDAP is this very support. Most mature applications will be able to interact with LDAP for security. This basically means that a lot of different and entirely unrelated systems in an organization will be able to share the same common authentication provider, which is very useful. Also, LDAP fits the role of an authentication provider well because it's a hierarchical system, which makes it well suited for mapping users in an organizational structure. Going into more detail about LDAP itself is not the purpose of this course, so we will assume at least a basic understanding of the protocol. We will start by defining an embedded LDAP server to authenticate against. We will then map the Spring Security authorities to the LDAP structure so that we can perform authorization. And we will finally do both authentication and authorization against an external, production-ready LDAP server. Let's begin the current section by adding the Maven dependencies that Spring Security will need to be set up with LDAP support. These are going to be Spring Security LDAP and the Apache DS dependencies. So we're going to uncomment these and we're done. One quick note about the Apache DS version here. 1.5.5 is the last version that is working with Spring Security 3.1.3, although 1.5.7 does exist. Next, let's define the LDAP server we're going to authenticate against, and we're going to use the namespace support in our security XML configuration to define it. We're going to set up a basic embedded LDAP server, as it's much easier to set up than a standalone external full LDAP server. So let's uncomment the LDAP server element for which we have provided a root. This has created an embedded Apache directory LDAP server, but at this point the server is empty. To populate users into it, we will need to provide some initialization data in the standard LDIF format. We could simply add an LDIF file to our class path. Spring Security will scan and import the LDIF file on startup, or we could specify a specific LDIF file in our namespace configuration by using the LDIF attribute. But for our purposes, a single file automatically picked up by Spring will be fine. So let's take a look at our simple users LDIF file. This starts off by specifying an organizational unit called people and continues with defining 3 users. We are defining admin1, admin2, and user same as before. We could also take a look at the location of this LDIF file. This exists in resources, so it will be present on the class path. The final step is to change the old persistent-based authentication provider with a new LDAP authentication provider. We are also providing a pattern to retrieve the distinguished name, the DN, of the user. This is going to look under the organization unit people under which we have created our users. And this expression is also necessary for the username to be bound during the authentication process. So let's now see this working in practice. We're now logging in with admin1 and we're getting a 403 forbidden. So what does that mean? For one thing, it means that we were indeed able to authenticate correctly. If we hadn't been, we would have received a 401 unauthorized instead of this 403 access is denied, and the Spring Security login mechanism would have redirected us back to the login form. So the 403 means that while we have indeed authenticated, we do not have the right authorities, and so we cannot access the authenticated page. So let's go back to our Spring Security XML configuration and look at the authenticated page. As we can see, this was secured with role user, which our admin1 user no longer has at this point. What we can also see is that we do have an open HTML page which just required the user to be authenticated with no specific roles. So we should be able to access that. And indeed we are. This page only requires the authenticated user, which is why we were able to access it. At the end of this video, we implemented a simple authentication scenario with LDAP. In the next video, we will focus on authorization. In this video, we will focus on authorization with the embedded LDAP server we defined in the previous video. We will focus on how to set up and retrieve the user's authorities from LDAP and on some of the more advanced customizations available to us in the namespace. We will start by defining the authorities of the users in the LDIF setup file. We will then configure Spring Security to read the authorities from LDAP, and we will show how to fine-tune this search query to adapt to a more complex LDAP structure, which is very common in production environments. Let's start with the data from LDAP. In the previous video, we had user data defined in the LDIF file. Now we need to add role data into this file as well. This will represent the user's authorities in Spring Security. So we have added the organizational unit for roles, and at the end, we have added the roles themselves. We are defining the user and the admin role, exactly like in the previous sections, and each of these roles is defining its members. So, for example, the user role is defining admin1, admin2, and user1 as having this role, and admin is only defining admin1 and admin2. Next, we'll set up the Spring XML configuration to interact with LDAP not only to authenticate the user, as in previous videos, but to retrieve the authorities as well. Since the roles were defined within the roles organizational unit in the LDIF file, we need to specify the root node from which the search will start in LDAP via group search base. And since the role definitions were using member in the user's LDIF file, we'll need to specify a custom expression to search for these roles in LDAP. So let's uncomment this, restart the server, and let's make sure everything works as expected. So we're logging in with admin1, and indeed we are able to see the authenticated page and everything is working as it should be. At this point, we have a working authentication and authorization process with LDAP. We were able to define an embedded LDAP server, populate it with both user and role data, and successfully configure Spring Security to authenticate and load up the authorities of a user. Now that authentication is working as expected, let's take a look at the additional customizations that we have available for LDAP. Our user structure in LDAP is a simple one. We have all of our users under a single people node. However, with a more complex LDAP structure where that may no longer be true, we have the option to locate the user in a more flexible way. We can do that via the namespace. We can specify a search base to locate the root node where the search for the users will need to start, and we can specify a search filter. Let's restart the server and let's make sure we can still log in as expected. Keep in mind that the user's login name will be substituted for this parameter in the filter, so it will search for an entry with the UID attribute equal to the username. So let's see how the login performs. We are logging in with admin1, and we are indeed able to see the authenticated page. And we are logging in with user1, and we are also able to see the authenticated page just as expected. So at the end of this video, we have implemented in practice the authorization process against the embedded LDAP server we defined in the previous video. In this video, we will look at how to set up our security configuration to use an external LDAP server instead of the embedded one created by Spring Security. We will start by setting up an external LDAP server using Apache Directory Studio, and we will continue by setting up Spring Security to use this new external LDAP server both for authentication and authorization. Let's start by looking at the structure of the embedded LDAP server with Apache Directory Studio. We need to define the connection, so this is using the default port that Spring Security will start the LDAP embedded server on. Checking network parameters is successful, so we can go further. We do not require any sort of authentication for this, and we're done. We can disregard this error. So now we can start exploring the LDAP data that we have created via our user's LD file. Next, let's start up the external LDAP server. This will be an Apache DS 2.0 server with the same data that we had in our embedded server. So let's start this up. And we're done. We now have a working standalone LDAP server that we can authenticate against. One important detail to keep in mind regarding the configuration of this server is that for the time being it is allowing anonymous access. Next, let's change our security XML configuration to use this external LDAP server. First thing we'll need to do is specify a URL for the server. This is running on localhost and the default port is 10389. We also need to specify the path to the partition we are using in the external LDAP server. So let's uncomment this and try out this configuration. We are going to log in with admin1 and we are logged in. Not only we are logged in, but Spring Security has managed to retrieve the authorities necessary to access authenticated HTML. So Spring Security was able to successfully authenticate against the running standalone LDAP server. However, in a production scenario, the LDAP server is going to be configured to not allow anonymous access. So let's change the server configuration and restart the server. So let's now try to again authenticate with admin1. We are no longer able to log in. So let's check the logs. And what we are seeing here is an authentication exception, which is saying that the LDAP bind operation has failed. In order to solve this problem, we'll need to configure the authentication credentials to access the standalone LDAP server. So let's specify the credentials. We're going to specify the user and the password. And for this we're just using the defaults in Apache DS. So let's restart the server and log in with admin1. And as expected, we are now fully able to log in and access authenticated HTML, which means that Spring Security was able to interact with LDAP again. At the end of this section, we are now able to set up both an embedded LDAP server as well as a full standalone LDAP server with Apache Directory Studio. We are also able to populate data into both of these servers using Spring Security and the namespace support. And finally, we are able to configure our security mechanisms to use these servers both for authentication as well as for authorization in a production-ready scenario. In this section, we will focus on authorization. We will discuss and demonstrate practical examples of using Spring expressions in a variety of use cases and scenarios. We will start by securing full URLs using a wide range of Spring expressions. We will then do in-page authorization using the same expressions. And we will finish by using some of the advanced method-level security mechanisms that the framework provides. In some of the previous sections, we used in practice two Spring expressions to secure has role and has any role. And to recap, has role simply checks if the currently authenticated principal has an authority or not. Has any role is similar. It checks if the authenticated principal has any of the listed authorities. So let's now secure this expression page with some additional expressions to get a better understanding of what these are and how they can be used in practical scenarios. So let's start with isAnonymous and make our way to the more secured expressions starting from this one. IsAnonymous will check that there is no authenticated principal in Spring Security. So let's change hasRole with isAnonymous and restart the server. So what we should now see is the expression page be accessible before login, and it is, but not be accessible after we log in. So we log in with user, and then we go to the expression page. And as expected, we get back a 403 because the page was secured with isAnonymous, and we are now logged in, so we are no longer anonymous. Next, let's use isRememberMe to secure the page, and let's restart the server. Now keep in mind that we are still using the login form to log in, so in our current session we are not authenticated as RememberMe. This is a subtle but important difference. So what we will have to do is wait for a full minute for the session to expire, and then we will be a RememberMe enabled principal. So now that the full minute has passed, we can refresh the page and we will be a RememberMe enabled principal. So now we should be able to access the page. And we are. Now let's check that we can only access the page when we are a RememberMe principal. So we're going to log out, log in again, and this time we are not a RememberMe principal, and we are no longer able to access this page. Next, let's look at isAuthenticated. So before logging in, we should not be able to access the page since we are not authenticated. And indeed, we are redirected to the login page as we were not able to access the expression page. So let's now log in, and we can access the expression page as we should. Okay, now let's log in with RememberMe enabled, and let's wait for a full minute for the session to expire. Okay, so now that the minute has passed, let's refresh, and at this point we are a RememberMe user. Now the RememberMe user is still authenticated, so we should still be able to access the expression page. And we are. For the next expression, we are going to look at isFullyAuthenticated. So let's secure the expression page and restart the server. And note that the RememberMe enabled user is not a fully authenticated user. So let's log in with RememberMe active. And let's wait for a full minute to pass and the session to expire so that we can become a RememberMe user. So the minute has passed and we are now a RememberMe user, and we should no longer be able to access the expression page. And we are not. We are getting the 403 access is denied as we should be. Next, let's look at a more advanced and fine-grained expression, has IP address. This is true if the client's IP address matches the specified IP address in the expression. IP address can either be a simple IP or a range. So let's try this out. We have specified an address that does not match our own localhost IP. So let's restart the server and let's see that we can no longer access the expression page. We are going to log in, and indeed we are no longer able to access it because our own IP does not match the one specified by the expression. Okay, so let's change this for localhost IP6 enabled, and let's restart the server. And at this point we should be able to access the expression page since the expression we specified did actually match our own local host. And indeed we are. We are fully able to access the expression page just as expected. Finally, let's write an expression using the raw request object directly. We're going to secure the expression page to only be accessible for post methods. So let's restart the server and let's try to access the page. Since the browser was sending a GET request and the expression was configured to only accept POST requests, we are getting the 403 access denied as expected. Let's now open up a RESTful client, and for the purposes of this demo, this is a simple HTTP client, and let's send a POST request to this page. And we should be getting back a 200 OK since POST is permitted to access the page. And indeed we are getting back the 200 OK, so the security expression is working correctly. And finally, Spring security expressions can be combined into new, more flexible and more powerful expressions using logical operators, as we have already seen in section 1. At the end of this first section, we used in practice most of the expressions available in Spring Security. We used these expressions to secure the access to a full page by its URL. In the previous section, we used several Spring expressions to secure the URL of a page. In this section, we will use the same expressions to secure only part of the JSP page, not the page itself. The goal here is to be able to show conditionally some part of the UI based on these expressions and the currently authenticated principal. We are going to work within the expression page and define some text. This text is the visual element that we are going to secure throughout the course of this section. So first, let's see how this looks without any kind of in-page security applied. As expected, the text is displayed. First, in order to be able to secure the text element, we're going to be using the taglib support defined in Spring Security. So let's enable this in our JSP page. And now that the tags are available, the authorized tag is going to be the focus of this entire section. So now let's wrap this text in the authorized tag, and for this example we will be using the simple has a role admin expression. And let's restart the server and see how this affects the displaying of the visual element. So let's start by logging in with admin, and for admin the visual element should be correctly displayed. Now for user, we should no longer see the visual element, and we are indeed not able. Is anonymous, is authenticated, and is remember me work pretty much the same way they did when we were securing the full URL of the page in the previous section. So we won't go over them again here. Next, let's look at one more expression. We are going to use the raw authentication object in an expression to verify not the authority of a principal but something else. So let's choose to only display the text element for our admin2 user. So as we said, we are going to work against the authentication object, and we're going to compare the name with admin2. This is when the expression will be true. Let's restart the server, and let's log in with admin1 and make sure we can actually not see the visual element. And indeed we are not able to. Let's now log in with admin2 and make sure we can see it. And the visual element is displayed correctly. The authorized tag element is more flexible than just allowing expressions and the access attribute. The tag also allows access to be configured not based on a specific expression, but based on the access a user has to an URL. This essentially means that if the user has sufficient access to the URL, then the authorized tag evaluates to true, and so its contents are displayed. Okay, so let's replace access with the URL. And we have chosen the dev-only URL because this was secured to only be accessible to the admin2 user. So let's restart the server and let's log in with admin1 and make sure we do not see the visual element being displayed. And indeed we don't. Now let's log in with admin2. And we get the visual element displayed on the page just as we should. The URL is more convenient than access because it abstracts away the security decision, which now no longer needs to be explicitly defined in the page as well. This mechanism allows the actual security rules to be kept in Spring XML instead of the UI pages. It also allows that these rules are defined in one single place and not scattered across multiple JSP pages of the application. At the end of this section, we are able to show or hide an artifact in a standard JSP page based on the roles of the principal, and we are able to use several types of expressions to do so. In the previous sections, we secured a full page by its URL first and then parts of the page. In this section, we will look at how to secure methods in our controller or in our service layers. But first, let's discuss why secure anything at either the controller or the service layer. And the answer is simple. Security is an application-wide concern, and we want to be able to share the security rules and the business rules across the entire application and have these rules applied however our system is consumed. For example, we may choose to publish a RESTful service and give the user an additional route to consume our system. If security is only defined for the UI and the RESTful service doesn't have anything to do with the UI, then this will not be secured. And in conclusion, we would have to double our work and independently secure the alternative REST service as well. So let's start by looking at the user's admin page without any sort of method security enabled. As you can see, the users are displayed in the page correctly. Now let's secure this method responsible for retrieving the users at the controller level. We are using the simple @secured annotation and just specifying the authority that we are requiring for access to the findAll method. Let's now restart the server and let's see how this affects the users table. We are going to log in with user1 and we should not be able to see the users in the table. However, this is not the case. Even though we are logged in with user1 which does not have role admin, we are still fully able to see the users in the table. The problem here is the fact that we have not enabled security annotations in our system. So let's do that now. We need to define the global method security element in our security namespace, and we need to explicitly specify the secured annotations as enabled. So let's restart the server and see that this time the users are no longer displayed in the table. And indeed we are getting the error to load the users, and the users are no longer displayed. If we log in with admin, we should be able to see the users being displayed in the table, and we are. The downside of @secured is that it's very limited. What makes this annotation limited is the fact that it doesn't support expressions, and this greatly limits the options and the flexibility to secure methods, especially compared to what we are able to achieve when we were securing URLs or page elements. So let's look at replacing this with a pre-authorized annotation. This annotation fully supports all the expressions that Spring Security has available. So now let's take advantage of the hasRole expression for role admin. Same as with the secured annotations, we need to enable these new annotations as well. We do this with the pre-post annotations attribute still on global method security. So let's restart the server and let's make sure the pre-authorized annotation works as expected. So let's log in with user1, and with user1 we should not be able to see the users in the table, and indeed we are getting this error. Now let's log in with admin and let's make sure that we are indeed able to see the users as we should be. And indeed we are. Alright, let's finish by looking at a more advanced example of using these security annotations. We're going to be looking at the method for retrieving the user by its identifier. Now, what we want is admin users to be able to access everything, all users in the system, but we want standard users to only be able to access their own data, namely their own user resource. Essentially, what we need to avoid is a standard user accessing the details of another user. Okay, so let's analyze this security expression. As you can see, we are using the OR logical operator to combine two individual expressions into one that will better suit our needs. The first expression simply checks if the user is an admin. This is the hasRole standard expression that we have used before. It is the second expression that will be much more interesting. First, notice how we are accessing the role principal and we are looking at its ID. Notice how the expression refers to a user ID. Also notice how the parameter of the method is user ID. So what's happening here is that the expression actually refers to the parameter of the method and uses it when the expression is evaluated. So just to recap, what the expression is checking is that the ID of the currently authenticated principal is the same as the ID of the user data that is being requested, making sure that the standard user can only get their own data. If the IDs match, the data will be returned. If the IDs do not match, access to the data will not be allowed. This is of course an advanced expression, one that is using logical operators, access to the role principal, as well as accesses the parameters of the method directly. Throughout this section, we used in practice several types of Spring expressions to secure our application. We started by securing a full page by its URL. We then secured parts of the page using the taglib support that Spring Security provides, and finally we secured Java methods at the controller level. In this section we will secure a RESTful web service. First, we'll take a look at how the RESTful web service is built and where security concerns are enforced. Then we'll set up some data by implementing a setup process with the secured service layer. Next, we will implement basic authentication for our REST service. we will write some integration tests against a deployed live service, and finally we will implement digest authentication. The REST architectural style has seen significant growth over the last few years, with major providers of web services replacing their old SOAP implementations with REST APIs. Most of these relatively new REST services have some sort of security, starting from the standard basic authentication all the way to complex homegrown solutions. And so securing a REST service is a complex subject, and one Spring Security, especially Spring Security 3.1, is very well positioned to address. Let's now look at a high-level overview of the architecture of the REST service that we are going to work with. First, we have the REST layer. This is built with Spring MVC for REST and Jackson or Xstream for marshalling and unmarshalling resources. Next, we have the business layer. This layer contains the services and possibly facades of the system. And finally, we have the persistence layer. This is Spring Data, JPA, and Hibernate. Now let's discuss security, and more specifically, let's discuss which of these layers is actually going to be the one enforcing the security rules. We could add our security rules and enforce them directly in the REST layer. The disadvantage of this approach is easy to spot. The application does publish a REST API, but it may also publish other types of APIs as well. For example, it may publish a pure Java API. And if security is enforced at the REST API level, then the other APIs will not benefit from it. This usually leads to a lot of duplication writing security rules twice, which of course we want to avoid. So we're going to go down one level and enforce our security constraints in the business layer of the application. And this way, all other APIs built on top of this layer would consistently use and benefit from the same security rules for the entire web application. In this first video, we will be looking at the REST service. This service is entirely implemented with Spring, but note that REST itself is not the subject of this course, so we will assume a working knowledge of it. We'll have a look at the Maven dependencies, at the controller layer, as well as the service layer. We will then look at where security concerns are actually enforced and implemented, and we will finish the video by implementing a setup process with the secured service layer. First, let's take a look at the Maven dependencies. Notice that we are not using Spring Security taglib, as this is a RESTful service, so there is no need for JSP support. The rest of the required dependencies are all present from the previous sections, so we will only need to enable one last dependency. We will enable Rest Assured in the testing scope to be used for testing purposes later on. Let's now look at our web XML. This has been simplified from the previous sections with the fact that we now only have a single servlet. We no longer need to define and map a servlet to handle HTML requests, as there are no HTML resources to be served. And now let's take a look at the most important part of the REST service. This is the controller layer. The user controller is a very simple and standard Spring controller. It does, however, present a few interesting pieces of information. First, notice that there are no security annotations in this controller whatsoever. We talked about the reason for this before. As security is an application-wide concern, this will be enforced in the service layer, as we'll see in a minute. Also notice that the responsibilities of the controller are very few. It handles request mappings, and implicitly it handles marshalling and unmarshalling of resources. And that is pretty much it. Now let's turn our focus to the service layer. As we discussed before, the security rules are enforced in this layer. We are using the very flexible pre-authorized annotation that has been introduced in a previous section when we discussed method level security, and we are using Spring security expressions to secure all our methods. And so, since security rules are enforced in the service layer, whatever controller is going to interact with the service layer is going to have the same security rules enforced as well. Let's now pay special attention to the find by ID method. This is secured same as all the other methods with a has-role role admin expression, but then this is also providing an alternative. This is working against the raw principal as we saw in a previous section, and this is comparing the ID of this principal with the ID argument of the method. The reason for this is to allow a user to access its own user resource even if that user is not an admin. Now that we have seen how the service layer is secured, let's move forward. For the next step, let's predefine some default users. This can be achieved in a variety of ways, from raw SQL as we saw in previous sections to using our own service layer. Using the service layer is of course the preferred way to do setup and also the most commonly used in practice as well. So for setup, we are using a simple application listener, listening for the context refresh event from Spring, and on receiving that event, it will create the authorities and it will create the users. Notice also that we have injected the iUser service and authority service support, so setup is actually done through the secured service layer. The logic of creating these entities is pretty straightforward. We are first checking that the authority doesn't exist, and then if it doesn't, we are creating it. Same logic applies to a user. We are checking that the user doesn't exist, and if it doesn't exist, we are creating that user. Okay, so let's start this up and let's see how this works in practice. Okay, so we are getting an exception. Authentication credentials not found. An authentication object was not found in the security context. So what does this mean? Well, it means that we are trying to use the service layer without being authenticated, which is actually true. Our security setup class is not in any way authenticated before trying to use either the user or the authority services. And since the service layer does require authentication, all operations against this layer fail as they should. So let's correct this. We are going to learn how to programmatically perform an authentication process with Spring Security. Okay, so what we need to do is to programmatically set an authentication object on the security context on the current thread of execution. And what is important to understand here is that in Spring Security, the security context holder is implemented as a thread local. So we are only working with the security context on the current thread, the thread that the setup process will execute on. No other threads of execution will be affected by us setting the authentication on the security context. And notice that we are using the standard username password authentication token as our authentication object, and we are providing a username and a password, but these hold no relevance for setup. And we are also providing a single simple granted authority of role admin so that we can actually access all the methods of the service layer. At the end of the setup process, we also need to clean up this authentication object we have set up in the beginning so that when this thread gets reallocated to a new request, there is no chance that the authentication is still present on the thread. So let's now run setup again and let's make sure everything passes this time. And we are done. Setup passes and data is correctly created in our system. At the end of this video, we have finished securing our RESTful service. We are now also able to programmatically log in and perform a fully secured setup process. In this video, we will focus on securing our REST service with basic authentication. We will show how to set up basic authentication in our Spring Security configuration. We will then focus on consuming the REST service with a browser-based REST client, and we will finish by implementing some live integration tests against the deployed REST service. Let's start by setting up basic authentication for our REST service. First thing we'll need to do is to configure how our application manages sessions. We need to keep in mind that this is a RESTful service, so we need to follow the statelessness constraint in REST. This essentially means no sessions. Our REST service will have no sessions whatsoever. We can configure this by setting the create session attribute to stateless. This will guarantee that our application will not attempt to create any session. Next, we will need to enable basic authentication. We can do that by simply adding the HTTP basic element to our main HTTP attribute. And this is it. The namespace support that Spring Security provides is powerful enough that HTTP Basic is everything we need to set up basic authentication for our service. Also notice that we have no intercept URL elements as we had before in our HTTP main element. This is because security is enforced by method level annotations. These are enabled and these are used in our service layer as we saw in the previous video, so we have no need for any intercept URLs. Finally, we'll need to modify our custom user details service to stop using the service layer. This is an important point to understand. Our service layer is now fully secured. This means that this user details service, which was previously using the user service to retrieve the user by its username, can no longer do so because it itself is not authenticated. So what we'll have to do is to make use of the raw DAO layer instead of the user layer. The DAO layer is just raw persistence, no security concerns are applied, so this suits us well here as we are able to simply retrieve the user by its username. And this is all. At this point our user service should be fully secured. So let's restart the server and let's try to consume a URI of the REST user service. We are going to use this REST client for Firefox, and of course any REST client or HTTP client for that matter would work just fine. So we are going to perform a GET on the /users URI to retrieve all user resources in the system. So let's perform this, and we are being prompted for security credentials. This is because we have not configured any security credentials when we sent the request, so the server challenges us to enter our security credentials. If we cancel, we will get a 401 unauthorized as we expect. However, if we do set basic authentication credentials, we are going to set the credentials for admin1, and we do send the request again, we are receiving the 200 OK from the server as we expect, and we are receiving the raw JSON representing our user resources. Let's finish this video by writing a simple integration test against our fully deployed REST service. We are going to use the REST Assured library. This is a straightforward HTTP client with RESTful support on top, so it's a very useful tool built specifically to test our REST services. We are now going to test the same operation, a GET on /users, retrieving all user resources in the system. And notice that this operation is not specifying any kind of security credential, so we are expecting back a 401 unauthorized. So let's run this test, and it is successful. The server is actually returning the 401 as expected. So let's now take a look at the second test. This is given authenticated by basic authentication. When resources are retrieved, then 200 is received. That means we are authenticated with admin1 and admin1 password, and so we are performing this request with full preemptive basic authentication credentials. So the response we should get back is the 200 OK. So let's run this test and make sure this works as expected. And we are good. We are able to verify the successful status code of the operation in a live JUnit test. At the end of this video, we should be able to set up in practice basic authentication with Spring Security for a RESTful web service. This third video will focus on securing our REST service with digest authentication. We will start by implementing digest authentication in our Spring Security XML configuration. We will talk about namespace versus raw beans and the support that Spring Security has for digest authentication in the namespace. And we will end this video by implementing a few more live integration tests against the deployed REST service. Let's start setting up digest authentication in our Security XML configuration. Similar to basic authentication, explaining digest authentication is not in the scope of this course, so we will assume a basic but working knowledge of the concepts. The most important thing about Spring security in digest authentication is that there is no namespace support for digest authentication, as we had HTTP basic setting up basic authentication. And so this is the first time that we will set up something in our Spring security configuration with raw beans instead of using the namespace support. This doesn't mean that Spring security does not support digest authentication. It actually does out of the box. This only means that in order to configure digest authentication, we cannot use the namespace as we did with basic authentication. Okay, the HTTP basic element was creating two artifacts. It was creating a basic authentication filter and it was creating a basic authentication entry point. So we will have to do the same with our digest authentication configuration. We will first configure a digest entry point, and so let's uncomment the entry point here. We have defined this bean for digest authentication entry point and we have configured the standard rel name and the key. And next we will need to configure a digest filter. So let's uncomment the filter. So the filter is a digest authentication filter and it actually needs the user details service and the digest entry point we have just defined. Okay, so now that we have our two beans active in the context, we will need to remove the old HTTP basic element as that is no longer needed, and we will need to configure our digest entry point as our main entry point for the HTTP element. So we are going to use the entry point reference and we are going to point to our digest entry point. The final step is to define our digest filter as a custom filter. We are going to set up digest filter and we are going to set its position using one of the three options we have for setting the position of a custom filter. We have after, we have the actual position, and we have before. We are going to use after, and we are going to set this up after the position of the basic authentication filter. And we are done. We have now set up digest authentication for our REST service. So even though there was no HTTP digest element similar to HTTP basic, the namespace support was still flexible enough to allow us to hook in our custom filter and our custom entry point and easily configure digest authentication. So let's test this out. Let's write some integration tests against the live service similar to the previous ones with basic authentication. We're going to start with the 401 given authenticated by digest authentication, and in this test nothing changes. Let's start up the server and let's run the test. And everything works as expected. This still passes and we are still getting the 401 even though we are now securing our service with digest authentication. Let's move to the second test. So given authenticated with digest authentication, so we have now authenticated with digest authentication and we are expecting the 200 OK from the server side. Let's run this test and verify that we are actually getting the successful code. And we have a pass. This means that we are now able to perform the operation and retrieve all user resources with digest authentication. And we are done. At this point we have fully implemented digest authentication with Spring Security and our RESTful service is fully secured. In this section we will discuss and implement domain level security with access control lists. But first let's start by answering the question, why do we need authorization with domain level security in the first place? Let's introduce a scenario. The users in our system control some objects, let's call them possessions. Each user has the right to work with his own possession objects only, as they should. Now let's say that one of these users wants to grant another user some privileges over his own possessions. Maybe read privileges or maybe full read-write. So how would we go about implementing this? We cannot use a straightforward role or privilege because we would have to build a specific privilege just for the possession objects of the particular user. And this, of course, would become very complex very quickly. So we have our challenge. And this is a very common requirement in a lot of applications. Okay, now let's talk solutions. There are, of course, several manual solutions to this requirement, but these all entail mixing business logic with security concerns. And this is something that we want to avoid. What's more, as the number of entities grows in our system and the number of such requirements will grow as well, security rules become more complex and manual solutions become unruly and hard to maintain and of course hard to test. The more mature solution to this problem is called domain object security. In short, it's a generic way of writing security rules for each domain entity using what is called an access control list, an ACL. ACLs provide granular access down to the single entity level. So we will start by looking at the ACL actors and we will understand what is the role of each artifact. We will then create the ACL database structure and we will set up the data. We will set up both basic data as well as ACL data. We will then enable ACL in our Spring Security configuration. And finally, we will start using ACL in practice. First, let's quickly go over the ACL artifact structure. The first actor is called the SID. This is a security identity. This can represent either a principal or a role. Then we have the domain object. This is composed out of two entities: the class, which is the actual Java class of the entity, and the object identity. The object identity is the main identifier of the entity we are trying to secure. And finally, we have the ACL entry. This is the actual permission. This can have one of 5 values. It is either read, write, create, delete, or admin. And so for each entity, we will have 5 ACL entries for each of these permissions. The ACL entry indicates whether the permission to that object is granted or denied to the SID. And with that, we finished the introduction to domain object security and to Spring Security ACL. This video focuses on the data structure for ACL. First, we're going to create the database structure for our basic data. We are then going to create the database structure for the ACL artifacts. And we will finish by setting up some data in our system, both basic and ACL data. Note that this video is very database heavy. It discusses in detail the exact tables and relations that represent the ACL artifacts that were described at a high level in the previous video. We're going to start by creating the database structure for the basic data. To make sure we run these scripts on a clear slate each and every time, we first drop the database and then we create it, and we also set it as default. We are then going to create the tables for account, this is our user, role and permission. These are the older artifacts used for security, and we are keeping these for simple use cases only where ACL may not be necessary. We are mainly going to use ACL to define security rules, but there are a few places where the old role and permission structure is still okay, and there is no need for anything more complex than that. Finally, we will define the table for the new possession object we introduced in the previous video. This is a straightforward object with a name and a foreign key back to the user. Okay, let's run these scripts and let's move forward to the next step. We are now going to set up the table structure for the ACL data. The Spring Security reference has scripts for Hypersonic SQL and PostgreSQL, but since we're using MySQL, these are slightly modified to conform with the MySQL syntax. We are going to create 4 tables: the SID, the class, the object identity, and the entry, and we have discussed what each of these artifacts represents in the previous video. So let's run this script and let's move forward. We can now see that the tables have been created. Next, before moving on to the data, we are going to define some simple procedures to create our entities. The reason we need procedures is that now, whenever we create a new entity, a new possession for example, we will need to define some ACL entities as well. We could do that by hand, but it would become overly verbose for any non-trivial amount of setup data, even for our simple example setup data. So let's run the script, and we are going to discuss the details of these procedures later on, but for the time being, let's just define them. Now that the schema structure exists for both the domain entities as well as the ACL artifacts, we can start thinking of the data. We'll start with the basic data. We're essentially defining our users, our permissions, and our roles, and the associations between the permission and the role. So we'll start by defining three users, user 1, user 2, and user 3. We are going to define one permission associated with the role user, and this permission is still in use in the MVC layer, where it is well suited for securing full URLs. Okay, let's run this, and let's move forward to possessions. So let's now create some possessions, and this is where ACL first comes into play. The procedure to create a possession will create a few other things as well. So let's take a look. It is first creating the possession and keeping track of its ID. It will then create the ACL object identity, and this will point to the possession class, to the ID of the possession, and to the SID. And finally, the actual ACL entries will be created. This will point to the ID of the previously created object identity and to the ID of the SID. So 5 new ACL entries are created, each representing one specific permission. Okay, let's run this, and we should be done. At this point, we have a basic understanding of how the ACL structure works, how it's mapped to the database, and how to create ACL data in practice. We have also finished setting up all of our data, basic and ACL, correctly in the system. Now keep in mind that ACL is a complex subject, and to fully understand it, it takes both time and practice. And of course, this sample project over on GitHub is a good place to start. In this video, we will start implementing the project and setting up the ACL configuration. We'll start by mapping the Java entities to the table structure we created in the previous video. We will then configure the persistence layer of the application for all the new entities. We will set up ACL in our Spring Security XML configuration. And finally, we'll secure our first method with our first ACL security rule. At this point, everything has been created at the database level, the table structure for the basic data and for the ACL artifacts, as well as the actual data. So let's quickly recap. We have a few users, and the ACL data is set up so that each user can access its own possession entities, but not the possessions of any other user. The first step to setting up ACL in our project is going to be defining the Maven dependency necessary for Spring Security ACL support. This is Spring Security ACL. So let's uncomment this. Now out of the box, ACL makes use of EHCache, so we will need to add EHCache to our project as well. And we will also need the Spring Core EHCache support, and this comes in Spring Context Support. So we have uncommented these two dependencies as well. And finally, for our persistence layer, we are using Spring Data, and we are using Hibernate with MySQL. ACL itself uses raw JDBC support, and Spring JDBC is already a dependency for the project, so we don't need to add anything else. Now it's time to take a look at how our model maps to the domain table structures we have defined in the previous videos. So we have 4 tables for our domain data, and we have 4 entities defined in our project, each mapping to a table. We have our account containing some standard user information and the roles. We have the role and the permission, which are standard entities, but for the purpose of our project, which will rely heavily on ACL, these can be considered legacy entities. The only place where these are actually going to be used is the MVC layer to secure full URLs. And finally, we have the possession entity. This entity has a many-to-one back to the account, since the user is the owner of multiple possessions. The ACL tables and data already maps to the ACL support Spring Security brings, so there's no need to map any of those explicitly to new entities. Now let's briefly look at the persistence layer. As I mentioned before, we are using Spring Data to keep the DAO layer simple. So like in the previous sections, Spring Data allows us not to provide any sort of implementation for this DAO, only the interface is enough. Next, the transactional service simply delegates to the DAO. Each method just delegates to the DAO. And notice that it is here that we are going to add and enforce our ACL security rules. And we'll look at that in a minute, but for the time being we are only interested in persistence. And finally, since ACL uses raw JDBC to do its work, from the point of view of our application, the ACL persistence is fully transparent. Finally, our controller layer. The possession controller delegates to the service, and for the purpose of testing out ACL, we don't need a lot of operations in this controller. In fact, find one by ID is the only operation that we're actually going to need. Okay, now let's focus on the actual ACL configuration in Spring Security. We have defined all the ACL beans in a different XML file, simply to keep them separate from the standard web security definitions. Okay, the main actor in the ACL configuration is the ACL service, and this has three dependencies. It needs the data source, and this is our standard data source that has already been defined in the persistence configuration, so there's nothing more to define here. A lookup strategy, so we are defining the lookup strategy bean, and the ACL cache. Remember that we mentioned that ACL uses EH cache, and we have introduced EH cache in Maven, so we are using it now. Now this entire mechanism is flexible and is meant to allow custom implementations to work with their own data structures and their own persistence providers, and to do advanced customizations, but out of the box Spring Security ACL only comes with a single JDBC backed implementation for all of this. So the lookup strategy is a basic lookup strategy, and the ACL service itself is a JDBC ACL service. And finally, we also need to define an expression handler, and this needs a permission evaluator. These will deal with the actual mechanism of evaluating the ACL conditions and rules that we will be defining in our project. And we are done. The ACL mechanism is now fully configured and fully integrated in our Spring context. The last step before testing things out is to define a new security rule using ACL. We're going to secure a method in the service layer, so let's secure find by ID in the possession service. Now there are a few things to note here. First, notice that we are using post authorize. So what does this mean? Well, first it means that we do have to have pre and post annotations enabled in our security context. So let's check that we do, and indeed we do. So we can now use pre and post annotations. Now the reason we need to run the ACL security mechanism after the method has executed is because the expression itself is using the return object. So this is using the possession entity which is returned by the find by ID method. A side note here is that as opposed to pre-authorized security expressions, this will impact performance because it does actually go to the database and it does actually retrieve the possession object. Next, notice what kind of permission we are securing this method with. We are requiring that the currently authenticated principal has read permission on the possession entity. Remember that ACL defined 5 types of permissions and read was one of those 5. Okay, so we have enabled the annotation, so let's now start up the server and let's finally see all of this in action. Okay, to test the behavior of ACL, we are going to use the same REST client we used in previous sections, and we're going to request the possession resource with ID of 1. So let's first request this resource without any sort of authentication. The browser does recognize the basic authentication security challenge and prompts us for credentials, but if we cancel, we are getting the 401 unauthorized as we should be. Now let's authenticate with user 1. So we're going to specify user 1 and the password. And let's repeat this request. Okay, so as we expected, we are now getting 200 OK because user 1 is actually the owner of possession 1. Now let's change our authentication and let's authenticate with user 2. Now when we send this request again, we should get back a 403 forbidden because this time user 2 is not the owner of possession 1. Okay, so the server responded with a 403 forbidden as we expected and everything looks good. Finally, at the end of this video, we are now able to configure and set up a fully working authorization mechanism using Spring Security ACL. In this video, we will deal with a more advanced use case for ACL. We will grant permissions over a single entity of a user to another user. By this point, users have access to their own possession entities and no user can access the entities of another user. This is a very common scenario where a user would select another as the admin over his artifacts. Okay, so let's now say that user 1 wants to grant user 2 read permissions over his possessions. We're going to implement this in SQL so that we can discuss all the low-level details and we can understand what's going on. Spring Security does provide mutable operations over all the ACL artifacts, but in order to really understand the mechanism, that solution would be too high level. Okay, so let's first check what the create possession procedure was doing when it was creating the possession and giving the user permissions over it. So we only need to deal with the ACL entry insert because the ACL entry is where the permissions are kept, so this is what we are interested in right now. So let's pick this up and let's start modifying it to suit our purposes. Okay, our goal is simple. We want to give user 2 permissions over possession 1, which belongs to user 1. So the seed we are granting the permissions to is the seed of user 2. So the seed of user 2 is of course 2. So we need to fill in 2 for all of these 5 permissions. Now the possession object ID is the ID of possession 1, which is 1. And that's it. We are done. We now have a clean insert operation to run. This should result in our user 2 now having permissions over possession 1 of user 1. So let's run this and let's try this in action. We are now authenticating with user 2, which we saw at the end of the previous video wasn't able to access possession 1. Of course now it should be, so let's run. And indeed it is. We are getting the 200 OK as we should be, and so user 2 is fully able to read the possession 1 resource which doesn't belong to him. And finally, let's look at the filtering capabilities of Spring Security and at how we can use ACL with the post filter annotation. We are going to implement a find all operation which is going to be returning all possession resources in the system. Of course, we want this operation to only return objects that the currently authenticated principal has permission to read. So for example, when we authenticate with user 1, we should only get back possession 1, since that's the only possession object that user 1 can read. When we're authenticated with user 2, however, what should we get back? Well, first we should get back possession 2 and 3, since user 2 does have access to these objects. However, since we have just allowed user 2 read access to possession 1, we should get back possession 1 as well. Okay, so let's now activate this new filter annotation and notice that we are filtering the return list of possessions to only contain the ones that our currently authenticated principal can read. Okay, so let's now restart the server and let's see this in action. Okay, so in the first step, let's ask for the possession objects from the server without specifying any kind of authentication. So we get back the 200 OK, but notice that we are not getting back any possession objects from the server. Okay, let's now authenticate with user 2 as we discussed. And let's ask for the possessions again. And what we should get back is possession 1, 2, and 3. And indeed we are getting back possession 1, possession 2, and possession 3. So the server is correctly filtering out the results based on the currently authenticated principal. And this is the power of ACL. We no longer need to operate with whole groups of objects or principals. It allows us to work much more granular with the individual entity and give or restrict access to that entity in relation to a single principal. And as you can see, this is far more powerful than the previous mechanisms with roles and permissions.